All right, so this video is going to focus on 10.7. And remember, for 10.7, it's very important that you understand box and whisker plots, which we talked about in a previous lesson. But the very first thing this talks about, find the median. Well, you first have to put them in order from least to greatest, which these appear to be, and then count to the middle one. Median means middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have to go in 4.5 essentially, right? 1, 2, 3, 4.5. It's right here. And then 1, 2, 3, 4.5 is right here. So it means that 12 is my median. For this one here, I have 1, 2, 3, 4, 5, 6, 7. So I go in 3.5. 1, 2, 3.5. I go 1, 2, 3.5. So it looks like 62 is my median. For this one here, again, they're in order from least to greatest. Very easy. 1, 2, 3, 4, 5, 6, 7. I go in half, which is 3.5. 1, 2, 3.5. And 1, 2, 3.5. So 37 is my number. This one here, again, it looks like they're in order. I have 1, 2, 3, 4, 5, 6, 7, 8. So I go in 4. 1, 2, 3, and 4. And I go 1, 2, 3, and 4. Now I have two different numbers. I have 78 and 79. In order to get the average between these, I have to add them together and divide by 2. So I have 78.5. For this one here, it appears that they're not in order from least to greatest. So the first thing I have to do is change the order. And I'm going to quickly do that. So I'm going to go through here, and the lowest is 32. And then I have 34. And then I have 35. And then I have 38. I'm just going to cross these off because I'm going to forget them otherwise. So I have 32. Well, the answer is 38. Try to cross these off. So I have 32, 34, 35, 38. So then I have to do 42, 43, 45. And I have 1, 2, 3, 4, 5, 6, 7. So I go in 3.5. 1, 2, 3.5. 1, 2, 3.5. That's how I get 38. And you do the same thing for the last one. Now, we're going to talk about a few things today to make sure that you really understand. Now, one thing you have to understand is what MAD is, and it's called the mean average deviation, which seems kind of strange, and you're trying to figure out why you'd actually use it. But what it basically means is if I look and I find my median, my mean score of this data. So if I go through here and I would add them all up, so like I have 50 plus 60 plus 60. In fact, let's just do this. So I'm going to go 50, 60, 60, 70, 70, 80, 80, 80, 90, 90, 90, and 100, and 110 twice, and 120. So I'm going to quickly add all these up. Let me just get a calculator. All right, so I'm going to go through here and just quickly go 50 plus 60 plus 60 plus 70 plus 70 plus 80 plus 80 plus 80 plus 90 plus 90 plus 90 plus 100 plus 110 plus 110 plus 120. And I get this 1,260, big number, right? And I have to divide it by the amount that there were. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm going to say minus or divided by 15. And I'm going to get 84 as my answer. I'm going to write this down. So I have 84 is my mean. Now, in order to figure out the mean average deviation, I have to actually go through each of these numbers, and I find the absolute value between 84 and 50. So like I'll take 84 minus 50, and I get 34. And all these numbers will be positive, because it's the absolute value of them. This here, between 84 and 60, that's 24. This is 24. This is 14. This is 14. So all that I'm doing is I'm just taking the numbers and kind of finding the difference between them. This is 4, this is 4, this is 4. Again, these are absolute signs, so they're always positive. This here is 6, 6, 6. This here is 16. This is 26, 26. And this is 16, so this is 36. Now I have to add all these numbers up. So I'm going to do 34 plus 24 plus 24 plus 24. When I have two 24s, plus 14 plus 14 plus 4 plus 4 plus 4 plus 6 plus 6 plus 6 plus 16 plus 6, this that one 16, 26 plus 26 plus 36. And I have this number 244 divided by 15. And I must have added something wrong here. I'm pretty sure when I add all these up, if I did it right, it should equal 16. So I did something incorrect. I'm not sure where in my calculations, but this is my MAD, my mean average distribution. And the reason why I figured these things out is because when I'm comparing data sets, I have to look here and it says compare the population using measures of center. So for this one, it's 84 for the first one. Oh, it's approximately 16. So I guess I did do it right. So it was 84 for the mean, which I showed you, and it was 16 for the mean average deviation. Okay. Now I'm not going to do the same thing I just did for B, but these are the answers they got. 58. They took all this and added them up, got 870, and then the mean average deviation here is 16. And the way that you express the difference in measure of centers, the way that of a multiple, is I would actually take this. I take 84 minus 58 divided by 16 because they're both the same. So 84 minus 58 is 26. 26 divided by 16 is 1.6. So this is this is the multiplier of variation that we have between the two. Now, how does that help us? What it tells us is it tells us, number one, if I look here, this person spoke longer than this person. They both had the same average deviation between that. So they're consistent. They're comparable to each other. But this one candidate talked a lot longer. And then when I want to express the difference in measure of center as a multiple, this is how you figure it out. This is how we do. This is what the procedure is to figure it out. So it says, what if we now change it so we increase by 30 seconds? How does this affect the answer? Well, this is what's going to happen. It's going to increase the mean by 30 points, but the mean average deviation shouldn't change at all. It's still going to be the 16. When I would take this and I have 114, which is what I have now, 114 if it goes up by 30, right? Minus 58, so let's just do that. So if I take 114 minus 58 divided by 16, and I get 3.5. And that's what it's saying is this new MAD. Okay. For this one here, it says you want to compare the cost of speeding tickets in 2 different states. Now it says there's only 10 speeding tickets that have been counted, and then you figured out a box and whisker plot based off of that. Now if I look here, remember each one of these quartiles is 25% of the data. So up to this point from here over is 75% of the data. And if you look, 75% of the data is less than 50% of this data, right? So on average, you'd think that B has more cost. Now A does have a higher cost, a ticket that's more expensive. There's kind of an outlier here. But if I look at data, it seems like a lot more of it's right up here, right? 25% is more than this 75% over here. But there's only 10 speeding tickets. We need a lot more data to do this, to figure things out. This one here, again, another 10. Now this is the speed of 100 sample speeding tickets. So I have 100. And if I look here, same kind of measurements, it looks like this data is significantly lower in terms of cost. So this is like 75% of the data is below 70, and 75% of the data on this one is above 75. So it looks like state B would absolutely have higher tickets. And the following, it says a random sample of 8 speeding tickets in state C has a median of 120. Can you conclude that the speeding tickets in state C cost more than A and B? I can't, because I need more than 8 speeding tickets. You probably need like 20, 30, 100, something. You need more data. So you really can't make that conclusion. This is a tough unit. Make sure you watch this again, and we'll talk